Okay, here we go again. So now we're going to look at how to find the sample proportion if we've been given a probability associated with a sampling distribution of the sample proportion. So looking at the same example we've been looking at, just to keep things simple. So the state unemployment rate for Texas in March 2007 was 4.3%. Let me highlight that. And now we want to find the 99th percentile of sample proportions for a sample of 250 people. So here we go. So I have 4.3%, which is 0.043 as a decimal. I have 99th percentile. And I have 250. So 250 is my sample size, so that's N. 99th percentile, that's the probability. And remember, percentiles give us the area or the probability to the left. Ooh, that got out of hand. Let's try that again. To the left. And then this unemployment rate of 4.3% is for all of Texas. So that's going to be our P. So again, we need to check and make sure we have a normal distribution using the central limit theorem of N times P times 1 minus P. Now the reason I'm doing this over and over again, we're using the same problem every time. When you are working through your homework and working through your classwork, every time you have a new problem with new numbers, you need to make sure you have a normal distribution. We don't want to be assuming anything is normal. We want to be in the habit of always checking that things are normal. So even though I know that this is normal, because I've already checked it a couple of times in previous videos and previous examples, I just want to keep building those good habits of always checking and making sure that this is a normal distribution. Because when I go into that 4-step process, it has to be normal for me to use that 4-step process that I'm going to jump into now. So this multiplication works out to 10.3, which is bigger than 5, so it is a normal distribution. So I can go ahead and say, okay, I've been given the area to the left, and I have something that is normal. So what is the first thing I would do? Okay, the first thing I would do is I would draw my curve. Here's my curve. It's not a very good curve. What would I do next? Okay, well next I would shade the probability, the amount of the curve that I was given the area for. So I've been given the 99th percentile, which means the area to the left is equal to 99%. So area to the left means I start coloring on the left, and I keep coloring until I've colored or shaded 99% of the curve. So I'm going to go past the mean, the middle, because that's only 50%, and I'm going to shade almost the entire curve. And where I stop shading, that's where this unknown z-score is that I need to go find in step 3. We're going to find the z-score. And we find the z-score using Excel. We type equals norm dot s dot inverse, and we type in the area to the left. So our area to the left is what we were given, 99%, which as a decimal is 0.99. And that tells me that this z-score is 2.3263. So far in this 4-step process, this is no different than when we were looking at an individual data value and no different than we were looking at the sampling distribution for the mean. The place where it differs, where we have to pay attention to whether we have an individual data value, a mean, or a proportion, is when we get to step 4. So now we're looking for the proportion, right? The proportion that falls in the 99th percentile. So we're going to find p hat. So the formula for that was back in the first video from this section. Oops, that's the wrong formula. My bad, my brain went on autopilot for a second. Ooh, it tried doing it again. What is my brain doing? Here we go. All right. So the z-score times the square root of p times 1 minus p divided by n plus p, the population proportion. So p hat equals, our z-score is the value that we found in step 3 times 0.043 times 1 minus 0.043 divided by 250. We take the square root of that, and then we add 0.043 to that. Be very careful plugging all of this into your calculators. Okay, I'm going to do the standard deviation first. You can probably plug this in all at once. I'm not working on my graphing calculator today, so I'm being just a little more cautious. Oops. So I came up with 0.0728. So the unemployment rate that falls in the 99th percentile is 0.0728. Or another way to think about this one, because this one can be a little bit weird on like, how do I think about this? If you were to go and take a sample of 250 people, 99% of those samples would have an unemployment rate less than 7.28%. The percent of people unemployed in 99% of those samples would be less than 7.28. Wait. Nope, I messed that second interpretation up. Yeah, less than 7.28%. Let me say that one more time. If you were to go out and take a sample of 250 people, 99% of the time, the unemployment rate for that sample would be less than 7.28%, or the probability of that sample having an unemployment rate less than 7.28% would be 0.99. You would be very hard pressed to find a sample of 250 people that have an unemployment rate more than that. Very small chance. Because most of the samples are going to have an unemployment rate less than 7.28%. So there you go. That's how you kind of work backwards. Find the sample proportion when you have been given a probability associated with a sampling proportion of a sampling distribution of the sample proportion.